Okay, if you notice, here we are given what is referred to as a differential equation. A differential equation simply means that it's a derivative, and derivatives tell us about slope. So for example, if I have f of x is equal to, say, 3x squared minus 2x plus 1, who could tell me what f prime of x is? 6x minus 2. And that works well because it is, in fact, it's a function, right? But if I give you this, x squared plus y squared is equal to 9, is that a function? It's not, because it makes what shape? A circle. And do you remember what kind of differentiation we had to use when we found that derivative? We had to use something called implicit differentiation. We said that the derivative of x squared was 2x. Do you remember what we said the derivative of y squared was? 2y prime, and the derivative of 9 is 0. So then we solved for y prime. Another way of expressing y prime was to say 2x plus 2y dy over dx. So y prime and dy over dx, those are the same things. And as you solve for dy over dx, which means the rate of change of y with respect to x, you would get 2y dy over dx is equal to negative 2x. And then divide, you get dy over dx is equal to, in fact, negative x over y. So that would tell you the slope at any given point. So what you have here is a bunch of derivatives, okay? We are going to sketch the slope field. And the slope field is nice and simple to calculate. We simply take the x value at a point in this situation and we add 1 to it. So I'm going to start along this axis right here. Can somebody tell me what is the x value right here? 0. What is 0 plus 1? So therefore, I'm going to sketch little segments that have a slope of 1 all across there. Can somebody tell me what is the x value here? It is 1, right? So if you add 1 to 1, you get... So I will sketch little segments that have approximately a slope of 2. Can anybody guess what the next one's going to be? And right now you might be thinking, how exact does my slope have to be? Not too exact. We should for sure see that it's positive. It should for sure look greater than 1. See, the last one's going to be 4. Let's start moving in the other direction. What is the x value here? Negative 1. So negative 1 plus 1 will give me 0. So in fact, you can see that we get 0. The x value here is negative 2. Negative 2 plus 1 is negative 1. So you have slope of negative 1 like so. And then finally, as you move to the last point in the back, you can see that the slope, or the x value here, is negative 3. Negative 3 plus 1 is negative 2, so you can draw little slopes of negative 2. Now I'm going to try to help you have a little bit of context for what this is. It's challenging to think about, and it's challenging in terms of the application, but I just want you to think of this for a second, okay? What is the antiderivative of x? Antiderivative. X squared over 2. Everybody agree if I take the derivative of x squared over 2, I get x? Do you also agree that the derivative of x squared over 2 plus 1 is also x? Do you also agree that the derivative of x squared over 2 plus 5 is also x? That any constant there would satisfy it, right? So what that means is if you were to take the antiderivative of x plus 1, you would get x squared over 2 plus x, correct? Plus some constant. So if you look at the field that you've created, the field creates, in fact, hi, thank you. it creates a parabola type shape. Okay, it creates a parabola type shape. So you can see what you have there. Now, the whole idea is that we don't know whether the parabola sits there or there or there because we don't know what constant would be added on the end. Can you see that relationship? Okay. Let's move on to the next one. What is different about number 2? It involves y. I like to think of where y is 0. Can somebody describe to me where y is 0? Along the x-axis. So that means along the x-axis, I have all these little slopes of 0. Do you want to go up or down? Okay, we'll go up. If I go up, what's the y value here? So what will the slope be? 2. Above that? 4. Below that? And below that, -4. What's different about number 3? You have x and y. So you need to take the 2 points and add them together in order to come up with the slope. This is going to take a little bit more time. I want you to go ahead and do it on your own after I do 2 with you. I will start here. 0 plus 0 is 0. If I go here, this is the coordinate 1, 2, 3. 1, 2. 3 plus 2 is 5. So go ahead and add them together. See if you could take some time and come up with the appropriate slope field. Go ahead, see what you come up with. Okay, I think we've seen enough. Please pause where you're at. I want to show you something that's important. Hopefully everybody saw that if you have opposite values such as -1, 1, that you should get 0, correct? So you should have 0 here and here. Should also have 0 here and here. Did you have that? Okay. And then in the other spots, for example, right here, okay, you have 1, 0, so the slope would be 1. Spot 0, 1, again, slope is 1. These should all be 1. And after that, 2, 3, 4, so on and so forth. So they should all be positive off to that side, and then they should be negative off to the other side, correct? So when the AP exam, so this would be a free response type question, so you will see, you most likely will see a problem like this. So out of the 6 free response, I would say that 3 out of every 4 years, there's a question involving a slope field. Now, there's a lot of extension from that. Getting the slope field correct would say give you 2 points out of the 9 that are available. So there's definitely more work to do. But they're going to be looking to make sure you have the 0 line correct, that you have positives, and then you have negatives from there. So hopefully your negatives turned out as well. Can we move on from that one? All good? Yeah. Can we skip the 2x? Except for the basic part. Where is it going to be 0? On the y-axis. Thank you very much. Make sure that you have zeros there. Tell me, to the right, they will all be positive, and to the left, they will all be negative. So I think you understand how quickly you could produce it from there, right? So we won't fill out every dot. On the AP exam, they will most likely give you, say, 9. So I've seen generally between 8 to about 16 dots that they ask you to mark out, okay? This is maybe a little bit more. The y minus 1, can somebody tell me where I will see a slope of 0? When y is equal to 1, where is y equal to 1? The horizontal line at 1. So all along here, you're going to have 0. Above there, what's the slope going to be? Positive 1. Very good. Alex and Minnie, you're both correct. And if I drop 1, then you can see you're going to have -1, -2, so on and so forth. All of a sudden, they become very quick in their calculation. Oh no, what is different about the last one? Definitely a fraction. And it's negative. We need to think about this. What's that? And there's 2. If we consider x, I first must realize that I can't divide by what value? I can't divide by 0. So you will put nothing wherever x is 0. Where is x 0? So I'm going to put these green dots, different from what we have, to let you know that there are no dots there. There is no slope. The slope is undefined in that situation. Tell me, where is y equal to 0? The x-axis. So what can you tell me about the graph there then? I will have 0. Is it okay to have 0 on top? Sure thing. So therefore, I will have slopes of 0 along the x-axis. After that, we begin to compute. We'll do a few of these. This point right there is 1, 1. So what will the slope be? -1. This point is -1, 1. So the slope will be 1. -1, -1. So that will make -1, and this will be +1. How about this spot right here? We're going to do a few more. I'm over 2 and up 1. -1/2. Whereas at this spot right here, -2. This spot, I am back 1 and up 2. +2. +1/2. Somebody make a conjecture for me. The slope of everything in the first quadrant will be, sure, reflected from here, will be positive or negative? Negative. Does that make sense? If we have a positive value and you plug it into there, it would produce a negative result. And so all of the slope here will be positive. They should all be positive here. And so you can continue to try to work those out if you would like to, and so on and so forth as you move down. Have the general idea for the slope field? Okay. Let's move along. Match the slope fields with their differential equations. So notice you have zeros here. Notice you have zeros here. You have zeros here. Here are your options. Go ahead and see if you can match. Take a few minutes, see what you can come up with. Okay. Where does A match to? How did you know? Yeah, if you look for a y value of 2, that's where you have zeros all the way across. Where did you match letter B to? 10. Notice that we have just x. X is positive here and here. X is negative here and here. X is 0 down the middle. So notice everywhere over here, it's negative going down. Here it's positive going up. And here it is 0. So that is the correct one. Okay. How about letter D? That is correct. X minus y. So if the two values are the same, they'll subtract and get 0. Notice whenever the values are the same, you subtract and got 0. And then this last one, obviously this matches with sine of x. Now what's interesting, if you draw the graph from here, notice how it kind of looks like that? What's that a graph of? Negative cosine. And what's the And so there you have it. What's the derivative of negative cosine? Sine. What's the antiderivative of x? X squared over 2, shape of a parabola. Okay. Some opportunities for you to try to make some connections. Go ahead and try this next one. Go. Try to match these. Start. Which one did you choose? That's what I'm interested about right now. Is where did you choose to start? You chose to start with A. You started with B. Okay, some people start with D. Lots of options all the way around. As I look at it, I actually started with the numbers. Did anybody else start with the numbers? So everybody can do it however they want. I really like starting with 12. The reason why is because wherever y is 0, and y is 0 along the x-axis, so I know that it can't be this, and I know it can't be that. It looks like if I take the y values positive, they go up, negative down. This matches C. The other one I really like, I also like 14. Because I look for when they're opposites, they'll be 0. And so I'm looking for opposites. When they're opposites, say -1, +1, or +1, -1, you can see you get that stretch of 0 right there. So this is A. What about 13? What do you notice about 13? Yeah, undefined value wherever y is 0, right? And so you don't have any slopes marked here. And if you remember from our very first problem I showed you, that was the derivative for a circle. And if you were to sketch, you get a circle. Our last one, if x was equal to 2, then you would get 0. And as you can see here, you have x is equal to 2 gives you 0. Anyway, all right, last example. You may be asked to identify which curve would fit through a slope field. So what does x squared look like? Show me with your fingers, your hands. Good. So we have that. E to the x, do you remember what the exponential function looks like? Excellent. E to the negative x, what if we make the x negative? That creates a horizontal flip, so it's going to go like that. Cosine? Yep. Natural log. Yep. Sure. Which one of those graphs do you think would fit with the slope field best? Definitely the natural log one. If you were to start drawing a function and kind of follow the segments, it would bring you over towards that way, wouldn't they? So in fact, this matches with the natural log graph. You try the last one on your own, number 16. See which function you think here would map into that slope field by examining them. Okay, what'd you get? Very good. It is the cubic. Excellent work. You have an introduction into slope fields. Let me talk about your assignment as it exists. On the front, you have 6 problems where you sketch the slope fields. You may take off the outer ring of dots. See what I'm saying? The outer ring of dots. So that leaves you with the inside ring of dots to do, which would be a total of 1, 2, 3, 4, 5, and then by 3. So 15 dots to do total on the inside for each one, okay? You can take off the outer. Any question on that? And then finally, on the back side, it is a matching exercise. Matching exercise. Okay, that is your assignment. Tomorrow, Monday, will be slightly, well, it will be very algebraic, and it will be a little bit more challenging. Good work.